inscribed angles, mostly. We're not really doing too much with central angles on these ones, but if you're not sure how to work with inscribed angles, go to the introductory video. Watch that first, okay? So I've got two triangles inscribed in a circle, okay? It's again asking me to solve for x, so my x is here in this corner, so I need to find the angle measure there for w, and then over here on this example, it's asking me to find the the arc measure of FE. Okay, so first thing I'm going to do, I like to do this either with a pen, pencil, or some colored pencils. Is I like to just mark out what am I ultimately trying to solve. Okay, so ultimately I want to solve this angle here on this guy, and then on this one I want to solve for this arc. So from F to E. Okay, F to E. I just want to, that way it helps me visually break it down. So the idea is, right, it's a triangle, 3 separate angles, each one forming this triangle. And so I'm looking at this, and this is a test-taking strategy. I need to start thinking, well, what do I know about triangles? Okay, well, if I add up all the angles, right, so I could say sum of all angles, that's 180 degrees. So say I'll just draw a little triangle, equals 180 degrees, right? So that's a fact we should have learned from previous maths. So then another thing I need to think about, previous knowledge, what might be useful. Well, for this guy, I'm looking at arcs, right? This is part of a circle, part of a circle, part of a circle. So I know that the sum of all those arcs, or the total number of degrees in a circle, 360. So 360 degrees equals full circle. Okay. Just little facts that we should have remembered from previous maths, and if we forgot, that's fine, but we need to start thinking about them now. Okay, so now I'm looking at this. Okay, I have an arc here, an angle, I'm looking for an angle, and then I've got some unknown down here of another angle. I know the sum of all angles equals 180. Is there a way I could maybe find this angle? Well, the answer is yes. So let me grab a different color here. I'll just highlight it in black. So what I'm going to be doing is, I'm going to look at this and say, well, 3 different angles, 3 different arcs in this. Well, Z, let's just see, do I know the arc? Okay, so there's one of its sides. Here's the other side, right? And then the included arc from W to Y, well, it gives us that measure, right? So think of it as I almost made an ice cream cone, okay? Here's the bottom of the cone, the scoop, it kind of melted, or we ate a bunch of it, okay? And I say that because some people kind of get confused, like, okay, does this go with this, or does this go with this? No, remember, it's always got to go across the circle to this other angle. So it's going to look kind of like an ice cream cone. It's going to look like a triangle with a little dome on top. Okay? So, I know from inscribed triangles that this is 2 times the measure of that angle. Okay? So I could say 2z, right, because we're looking at z down here, equals 32. So I'm going from arc to angle. That means I need to divide by 2. So z would equal 16. Okay, so I found that. There's 16. So that's really easy, right? Now, I could solve using this information. I have two of the 3 known as knowns. I don't know this one, so I could just write my problem as x plus 73 plus 16. It's all going to add up to 180 degrees, right? And then we just go back to our basic algebra. So I need to get x by itself. So I want x on one side, all my numbers on another. And so we'll just start while we're adding. So we do the inverse operation, subtract, right? I'm just kind of saving some space here. I'm not showing each sub-step, just to save some space. So I grab my calculator and say, well, what's 180 minus 16 minus 73? Right? So x equals 91 degrees. Cool. So I know what x is. I'm done. I solved the problem. This guy's a little trickier, right? Now, it wants me to solve for x. I'm given one angle, I have two unknown angles, and I have this arc here. There's two paths I could follow, okay? My recommendation is, yes, I could, figure out what this angle is, then figure out what this angle is, which would let me figure out this arc, but that's a bunch of extra steps. So when you're working with inscribed triangles, look at what are you looking for? So in this case, up here I was looking for x. I was given one of the angles. So it's really easy to see if I can find this angle down here, solve the problem, right? It's two steps. Here, the same idea. I'm looking for x. I have one of these arcs. I need to know this part of the arc. But I can find it because I know this angle. So let's just kind of highlight that in blue. We're going to take a side road, and I'm going to look at the blue arc. I'm going to solve for that first. Okay. Well, that's easy. Right angle, 90 degrees. So remember, I'm going from angle out to the arc, so I'm going to take 90 times 2. That's 180. So now I can say, well, full circle is, we said 360 degrees. I accidentally erased it by rubbing into it. Full circle. Okay. So let's do it. 360 minus, if I take away this arc, it's saying, here's these two arcs, so I'll subtract out the 320 arc. 20, not 30. And that will give me just this guy, right? So I said, I know the full circle, take out this guy, take out this guy. What's left? What's highlighted? X. So X would just be 60 degrees. And so those are the two basic problems when we're working with inscribed triangles. Next, we're going to switch over and talk about inscribed quadrilaterals.